Mhm. Oh, you can eat. I don't care. Yeah, just as long as if you. No, you're fine. Yeah, yeah. Remember, if you look at my class description, I said outside food and drink, totally okay. Just like if you make a mess, just clean it up and that kind of thing. If it's a drink, or don't worry, I'm not gonna watch you eat or anything like that. I'm not weird like that. I'm weird in other ways, but not like that. And so I was just gonna say I sent you the email in Canvas, so you may want to check it out because it has the YouTube video for that first lesson also. So if you want to take a look at that, follow along with that. Okay, guys. So I'm gonna go ahead and go to view classroom. View classroom. Yeah, I'm going to my classroom. So we're going to foundations here, and I'm going to go to foundations math. So were you able to, did you finish that locator or are you still working on it?
I just finished right now.
Oh, you just finished. What is it giving you? Just really quick. So we are going, so if you guys want to meet me here, I'm going to be in fractions. So we're going to be looking at that today. Now we're going to start in easy mode today with adding and subtracting them. But
By
before
the
we
end of this lesson, you will be able to add and subtract fractions that have the same denominator.
Okay, hey, that's fairly high. So that means you would be for reading. That would put you in like the pre-GED course, right? The kind of the middle. So let's go ahead and click exit. So that's fine. And let's see how we do on that last one. And that will kind of be the decider as far as,
Oh,
Okay, guys. Yeah, so we're gonna take this in pieces. Now, let's talk about fractions a little bit. Right? And we'll hopefully we'll touch upon it on our way. Are we gonna finish this today? We'll see. Okay, maybe maybe we won't. That's all right.
What is a fraction? Let's review.
Okay, so yeah, let's take a look at this. So this is exactly what I was talking about. A fraction, guys, represents part of a whole, right? So let's say I have this paper here, all right? So let's say this is our one whole, okay? Now, notice I have this paper. It's still the same size, right? It's still the same size, but I have this paper, this notepad. It's still the same size. However, we're going to say this is our one whole, right? And it's going to be one whole no matter what I do with it, okay? Let's say I tear it, I cut it into pieces, right? So let's say I'm going to signify that by, I'm going to signify that by, I'm going to make some lines here. I can't wait to go back to conference because conference I get to get another notepad from from the people that gave this to me. That's one of the nice things about going to conference. You get all sorts of free stuff. All sorts of vendors like this one I got a lot this past summer. It's like I go mainly to get free writing things, free bags, like this one right here. Just really quick, free bag from a publisher. They love to do that. Okay, so let's say I just a peek behind the curtain what being a teacher is like. So I still have this one hole, right? But notice, like I have cut it into sections, right? Um, so it's still the same paper, it's still the same size, right? It's still the one hole, right? That has not changed. The container hasn't changed, right? However, now I have sections inside of it, right? So now what I've done is I've taken this whole and I've, cut it into parts, right? It's just like when you make change. Think about when you make change, right? Let's say you got $1, right? And yeah, $1. Let's say you're going to make change for $1. Let's say you got to park somewhere, right? And the parking meter only takes change. My gosh, it's terrible, but it still exists, these days. And so you got $1, you go into the nearest change machine, or you have to go into a liquor store or something like that, right? And you plop down $1. It's like, hey, can you do me a favor? Can you break this up into 4 quarters, right? And so that's essentially what they're doing, right? You still have $1, and if they give you those 4 quarters back, it's still the same amount, right? It's just broken up, right? And so that's kind of the idea about fractions, is that fractions, it represents like pieces of whole. And that $1, if I really want to annoy and frustrate the person at the liquor store, say, hey, can you break this up into dimes? Or can you break this up into nickels? Or even worse, he's like, hey, can you break this up into 100 pennies? And, and it doesn't matter what that is, right? By the way, if you're going to do that, go to a bank. they'll just give you rolls instead of like separate, instead of separate pennies. They'll just give you rolls. I know I used to work in retail and I used to have to go to the bank to, make change to get change for the register. And so, but either way, it's still it's still $1, right? It's just been broken up into little pieces. Okay, so let's take a look at the parts of the fraction, right? So, and I use this a lot, so we gotta get used to using this language, okay? Because especially for fractions, I really don't. I mean, I'll do it, but usually I like to use the actual vocabulary because I want us to get used to that vocabulary. Because when we take the high set eventually, right, they may use, this language, right? So just remember, in a fraction, we have the top number, right? That's the numerator, right? That's the numerator. And the numerator tells us how many equal sized parts we have. So for example, right? So this tells us how many equal sized parts we have, right? So here I have 1, 2, 3, 4, 5, I have 5 equal parts. Now, let's say I take it apart, right? So let me fold this up to signify that I only now have, so now I'm going to fold it here. I'm going to remember this trick later on so I can show my evening class too. So now, okay, so now I've folded it in half. Okay, so take a look. All right, so now I folded it in half. So it's still a whole, but now there's only, 2 parts, right? You can only see 2 parts of that whole. And so I would represent that by saying, writing a number 2 on top. Okay, now, so the numerator is how many equal sized parts we have. Okay, so in this case, right, I had 1, 2, 3, 4, 5. Right, I had 5 parts here, 5 parts, but now I only have 2. I only have 2 equal parts, right? So I only have 2 out of 5 of those equal parts now, right? And so that's what we're doing here. Now, the bottom is called the denominator, right? The denominator tells us how many equal sized parts the whole is divided into. So basically it tells us, okay, how many spaces do we have available, right? So if you go into a movie theater, right, there's only so many seats that are available, right? So think of a movie theater as a whole, right? And let's say you are going to watch the really big summer movie of the year. I can't remember the last time I went into a theater and it was just like really packed. Probably when I went to see Barbie, the Barbie movie last year. I think that was the last time where it was like really like packed. Um, and they only have so many seats. Well, think of a movie theater as the bottom number, right? There's like a couple of, dozen seats available. That's your bottom number, right? But then as people come in and sit down, right, that top number is going to get smaller and smaller and smaller, right? Um, and so the front, and so that's how that numerator works, right? Is that the top number gets smaller and smaller and smaller as there are you know less space is available or more space, right? So that's kind of how it works. Okay, so there we go.
Best answer to this
Good morning,
question.
Mr. Gomez.
Hello. Okay, so let's go ahead and so we've kind of described any questions here. What is a fraction, right? I've kind of explained it in a couple of different ways. I explained it from kind of just a kind of a paper-based way. I've explained it in the way it works for money, right? Any questions here on that? Okay. And it's a really good idea to kind of embrace this idea or to understand this idea of what a fraction is, because once we get into the more advanced math, right? Because like last Wednesday or last Thursday, we were working on converting, right? Converting units, like converting miles to kilometers, right? Converting inches to centimeters, right? And in order to do that, we had to have a really solid understanding of how fractions work, right? So if I come upon something and you're not quite clear on it, or maybe you already did this lesson, this is your chance to, ask some questions, right? So let's take a look at this circle, okay? So this circle was a whole, right? This is a whole everything, right? Now we're going to say, okay, you know what? We have this whole circle, and we're going to divide this into 4 parts. Now, which is fine, okay? It's still here. Everything is still intact. Like if you think of this like a pie, which they like to do, I don't like to because it's pie, and then I start thinking about pie, and then I get distracted. Anyway, so I have this whole this is still here, okay? So this whole disc is still here. It's just now it's been cut up into pieces, right? It's still here. I haven't taken anything out, right? There's nothing missing. However, the whole circle is divided into fourths. It's divided into 4 parts. And these 4 parts make the whole, giving us the denominator, okay? So the 4 parts that make the whole give us the denominator. So I'm going to doodle a little bit. So I'm going to kind of illustrate how that works. So we have our 1 whole, okay? Now, give me a second. So we have our 1 whole. Now, the cool thing is that even when we split it up into 4 parts, it's still going to be 1 whole, because if I represent this as a fraction, okay, so I'm taking all the possible spaces here, right? And there are 4 possible spaces, but they're all filled right now. I mean, they're all present and accounted for, okay? It's just that now this, right, has become 4 parts. Okay, so that's what's happened here. All right, so let's continue. right? And so there's our denominator. So they kind of did it for us here, but you know, you kind of saw me do it just a minute ago. Now, notice we have a blank spot right there, and of course that's where our numerator is going to go, but we have to figure out, okay, what makes a numerator, right? Well, coloring one of these equal parts of the whole circle gives us the numerator, right? So there's a couple ways we can think about this. We can either think of fractions as splitting things up and taking things out, or splitting thing, you know, having splitting something into empty spaces and putting something in, right? Either way, the idea is kind of the same. And actually, for word problems, you're going to have to think back and forth in that way, because some fraction problems require you to, you know, have something split up and something is missing or taken out, or there's something here that's empty, like I think I use an ice tray, like an ice tray, and you're putting stuff in, right? So there's kind of two ways to kind of think about fractions here, and you will be expected to you know think of that in both ways. But for right now, whatever way makes you happy. Okay. Now take a look at this. So here, let's pretend we are taking something out. Okay. So let's pretend that we have let's pretend we're looking at the top of a wedding cake. Okay. Yeah, I like that because you know a lot of wedding cakes are white. Okay, so I like that. So let's go ahead and let's pretend that we're looking at the top of a wedding cake. Okay, like the direct top. Like, you know, here's our wedding cake, and it's like going, you know, let me draw a little heart here. There we go. Wedding cake. There we go. Okay. And so now, what are we gonna do? Okay, well, let's say this is a small wedding. Okay, maybe it's like a Vegas wedding. Maybe it's just like the two people that are getting married, and then two of their friends. Okay, all right, it's a Vegas wedding. It's like a tiny cake, and so we're gonna split this into four pieces. Okay, and let's pretend that the plate underneath, right? Let's pretend the plate underneath is purple, right? Let's pretend that plate underneath is purple, right? And, we can think of it as taking something out. Now, another way we can think about it, right? Like I said before, is let's pretend that we have like an ice tray. So let's think of this like an ice tray, like an empty ice tray. And we're thinking, okay, I have this empty ice tray. There's nothing in it right now. And let's say it's summer, it's hot, and my kids want like ice pops or something like that, and they want to go ice cream man. And I'm thinking, oh my gosh, I don't want to spend money on the ice cream man. I gotta buy real groceries, I gotta buy real food. And so I'll tell you what, I'll make some Kool-Aid, right? Some grape Kool-Aid, and I will make ice pops, right? Okay, so I'm going to take my ice tray, and my ice tray is empty. So let's say that this is an empty ice tray, right? So there's four available spaces here, okay? And then what you're going to do is like, okay, you know what? I'm only going to fill up one part of this ice tray with grape Kool-Aid. The other ones will have just regular water in it. Okay, we'll do that. So I'm just going to fill up one part of this with grape Kool-Aid. Okay, cool. Right? And so now in these four available spaces, because remember, this is still one hole, right? So out of this one hole, right, one space is now being filled. Okay, so that's one way of kind of looking at it. I'm trying for the life of me to think of other examples besides pizza and pie. I like the ice tray because with an ice tray, you know there's spaces there available already, right? Um, okay, I think let me check real quick. Might have missed something. And just any questions? Any questions so far? Like I said, I was gonna take it. I told you guys I was gonna take it really slow on this. Um, getting into this because I want us to make sure we know what a fraction is. What are we adding? So when we add fractions, like what are we adding? When we're subtracting fractions, well, what are we subtracting? Right? What are we doing with this actually? And of course, once we get to the more complicated math, right? That's gonna require division. You know, um, we should have like a hang of this, okay? And if not, like I said, I have lots of practice. I have lots of fraction practice in Canvas. So if Aztec isn't enough, I have extra stuff in Canvas. Okay. So I'm just making sure we are okay here. Okay. Great. All right. Okay, so let's go ahead and move on. So adding fractions by joining parts. Okay, so when we add fractions together with the same denominator, so no worries here. We're going to start in easy mode. Okay, so adding fractions with the same denominator is the process of joining equal sized parts. Okay, it's pretty much it's almost like if you're taking apple slices. If you're taking apple slices from the same size two, like let's say you have two identically same sized apples and you cut them up into parts, and then you're going to take those slices from one apple and slices from another, and you're going to kind of try to make an apple from that, right? It's kind of a way to think of it, but the apple has to be the exact same size. um, so in this example below, the two circles are the same size, and each is split into four. So therefore, we can add the purple parts together. It's fine. Think of that ice example. Let's say we have two trays of ice now, okay? So now we have two trays of ice. So we made our grape Kool-Aid, ice, pops, right? And so we had two ice trays, right? This is tray number one, so I'll just put tray one. And then here we have tray number two, right? And you know what? I'm like, this is taking up way too much space in my freezer. It really is. But thankfully, so I would like to take the ice pop that's in that one that's just kind of left here. And so I want to take that out and put it in the other tray. So that way I can put the other one in the dishes, right? Um, and so that way we can put the good cool thing is that it will fit. It should fit exactly into tray number two because guess what? The spaces are the same size. And so you're able to kind of add those, ice pops together. And that's how when we add or subtract fractions with the same denominators, that's really what we're doing. And that's why this when I say this is easy mode, right? because we don't have to really do anything. We don't have to change the size of the ice trays yet. That comes later. Okay. So let's go ahead and any questions? Any questions? Okay. So let's say I'm going to combine those ice trays, right? I'm going to put that one ice pop in with the other two ice pops. And what's going to happen is I'm going to get rid of this tray right here. And then this tray right here, I will now so I will have three spaces in my ice tray filled up, right? So that's how it works. So we have three ice pops in four spaces, four available spaces, which is really cool. Okay. So that's how this works. So if we were to represent this as numbers, this is how it would look. Because remember, guys, math is very representational, right? No, sometimes numbers and letters, they stand for something else. Okay? So that's kind of what we did here. So any questions? Any questions? Once again, because we're using the same size, because we have four spaces in this ice tray, and we have four identical spaces in this tray, we're able to, put them together. Not a problem. And how we did that is we just added the number of pops together. On this tray, we had two pops, we had one pop here, and so we just put the total number of pops on top, and then we put our spaces here on the bottom. Okay? What's another?
Am I able to do I was actually thinking of 3/4 because I was making a recipe and I had to get 3/4 of a cup.
Yeah.
And it had the actual cup I had 1/4.
Yes.
So I did 3 times the 1/4, and it actually became like a little argument because like, no, it's not right. Not using the right measurement. It's gonna be a lot less. I'm like, but it's 4. It's like it's 3 times.
It's the same thing. Uh-huh.
So I'm like, am I right or am I wrong?
No, you're right. No, that's right. I do that all the time.
He used the 1/4 3 times and it's still.
Yeah, it's 3/4. Yeah, exactly. Like if you were to, oh, yeah, if you were to get like a measuring cup, like a measuring cup, and you took those and you scoop that in 4 times, you would get about the same thing. It's not going to be perfect, of course, because sometimes you lose some of the flour or whatever sticks to the cup, whatever, but it should be about the same. Yeah. Yeah, exactly. And I do that too, because gosh knows, I'm the dishwasher and I don't even know where I put things sometimes. And like when I make French toast or something like that, it requires me to use specific measurements of because I have to use cinnamon, I have to use sugar, I don't use nutmeg in my recipe, although man, I wish I could, but my kids have allergies. But but I have to do that, but you're fine. Okay, so if you go back and tell whoever, so hey, you know what? I had a discussion with my teachers and Mr. Goins, we were talking about fractions that day, and he said I was right. Right, okay? All right, so there you go. All right, so okay, cool. Good. We still have some time yet. All right, so in this example, this actually looks like a real ice tray. This definitely looks more like a real ice tray. So let's say once again, still dealing with ice trays, making ice pops. This time we're going to use orange Kool-Aid, which is my favorite Kool-Aid flavor, by the way. Ever since I was a kid, my 2 favorite Kool-Aid flavors were lemon lime and orange, and it's really hard to find lemon lime. Easier to find orange. That's because when I was a kid, they had less Kool-Aid flavors. They just had your basic grape, cherry, strawberry, lemon, lime, orange. Nothing fancy. But okay, so here we are. So we have two ice trays, right? Now these ice trays are the same. Let's say you went to Walmart and you bought two ice trays of the same kind, right? And these ice trays are split into 6 parts. Well, once again, we're in that situation where it's like my kids, like okay, they left a tray in there that still has 2 ice pops, and I just want to get it out, get it out of there. Okay, so I want to move those 2 into the other ice tray. So we can do that, right? Because they're the same size, right? It's all split into the same parts, right? And so we're able to do that. We're just able to just kind of take them out and just, move them over, right? And that's why this is easy mode, because that's all we have to do, thinking about that. And that's what we're going to do. So we're going to take these 2 and we're going to put them with these 3 right here, and that's going to fill up, right? Almost all of it, right? It's going to fill up about five of the spaces. And that's okay. That's enough for me to get rid of the first ice tray and, put it in the dishes. And by dishes, meaning I have to wash it because I'm the dishwasher. So let's go ahead and any questions here? Any questions here? Okay, awesome. All right, so let's go ahead and go to the skill check. Okay, we're going to do this one together, you guys. All right. So what we're going to do is we are going to create an equation. You might thinking, oh my gosh, equations. That make you think of algebra or something like that. No, we've been doing equations ever since we started math in kindergarten. Okay, anything that has an equal sign where we have to add up, or subtract or multiply, is like anything that has an equal sign. We've been doing equations since we first started school. So let's go ahead and do that. So take a look at these. So once again, think of an ice tray. And you're thinking, okay, we have these 2 ice trays here. And these ice trays have 1, 2, 3, 4, 5, 6 equal parts, okay? All right, and this time we have blue. I don't know, what flavor? Blue raspberry? Okay, we'll say blue raspberry. Kool-Aid, okay? And let's go ahead and make an equation, okay? So at home, you can solve it if you like, but let's see if we can build it, okay? I'll give you guys about a minute to do that. Yeah, I'm just going to sit here and stare at the floor. So don't mind me. Okay, so let's go ahead and, make that equation. So we have 6, equal spaces. Remember, we put our spaces, how many available spaces we have, or how many total spaces we have. We put that in the bottom, not our available spaces, but just our total spaces. We're going to put that on the bottom. Now, on the top, so that's our denominator. Remember, I mean, I can use tops and bottoms, but I really want to call them what they are. So the denominators are going to be 6, right? Because that's how many total spaces there are. Now, here in this ice tray, I only have 1 space, one's part of this filled up. So I'm going to go ahead and put 1 here. And in this one, I have 3, right? So now it should look like 1/6 That's how we would say it. 1/6 plus 3/6. And of course, when the, you know, trust me, remember, think about that ice tray analogy, right? Because remember, what we're doing here is we're taking this one out, putting it over here. We're not making we can't, it's not like we can take these two separate ice trays and somehow connect them like Legos and make one giant ice tray with like 12 spaces, right? It doesn't work like that. So we're still have to deal with just one ice tray. So think we're moving this one part over here. We're putting this one in the dishes. We're forgetting about this one. And we're just keeping this one. So that's why the bottom number stays the same. Okay. And then we add the number, the total number of like ice pops that we have, and that would be 4. And so that should be it. Right? Okay, so there we go. Don't forget to do the explanation when you do these skill checks, okay? Okay, so I'm just checking time. Okay, we got time. Any questions here? Okay. Now, take a look at this. You cannot add fractions from different wholes, but look at this, because they're different sizes. Right? They are, the fractions cannot be added together. Like, guess what? If this is my, yeah, and this is kind of something we have to start wrapping our head around because, like, once again, this is going to come into play later on. Notice we have two ice trays. Let's say we bought 2 ice trays, and so we have, I guess, lemon. We'll say lemon. Or maybe we went to, oh, no. Let's say we bought Kool-Aid from the Food for Less, right? And we got the piña, like the pineapple flavor. That's what we did, okay? That one's pretty good too. Food for Less has different like Kool-Aid flavors. Sometimes I will go to Food for Less just for the different Kool-Aid. You know, they have mango and piña, right? All right, so let's go ahead and take a look at this. So notice, even though these trays are both have 4 available spaces, guess what? I can't really put this one piece into this piece because the space is just too big. And I definitely cannot put this one into this one. It's not going to fit at all. I mean, maybe this one will fit into the small one, but it's still not going to work, right? Because you're thinking, realistically, I could probably put that small one there. It'd be fine. Yeah, you could put that small one in there, but guess what? It's going to slide around and it's going to fall out and it's going to make a mess out of your freezer. And you're going to have to go in there and clean it, right? It's not practical. Both fractions do represent 1/4, right? That's fine. But because these two wholes are different sizes, these fractions can't be added. They have to be identical. Like the whole, right? The spaces, the available spaces, right, have to be identical in order for this to work, right? Okay, so that's what you're trying to say here. Oh yeah, see, they're using. Okay, we'll use pizza. Jeez, okay. For example, right? We got these 2 pizzas. They're both cut into 4s, right? But because the pan, right? The pizza is on. We can't be at. We can't. We're gonna have a weird looking pizza, guys. Like seriously, if we try to put this together, I'll illustrate really quick. So let's say we're gonna try to like make half a pizza with these 2 pizzas, right? Well, if we tried to do that with this half, this is the way it's gonna look, guys. So let's say we have one part of the pizza right here, And then we're going to take this one and we're going to say, okay, we have like, this is terrible. But it would look like this if you tried to like join it together. It looks like the Wu-Tang. Looks like the Wu-Tang logo. Looks like the Wu-Tang Clan's logo. But it's wait, sorry, I'm making myself laugh here. It's the end of the week. It's getting toward the end of my week. But you're like, yeah, it does. You're gonna have a weird looking pizza, right? It's not going to work. All right. All right, so let's go ahead and move on. All right, so yeah, so that's what they're trying to say is that this small slice and that no, try ordering from a pizza place and see how you react if you order a whole pizza and they give you like they cut it into parts and each slice is like oh, remember that whole controversy with Chuck E. Cheese and how like they were saying, oh yeah, Chuck E. Cheese, they're ripping people off because like if you look at their pizza, like they're totally different, right? Does anybody remember that? It was during the pandemic when everyone was shelter in place and people started noticing just weird details about things. Um, so yeah, that's like the kind of pizza you get, hon. Okay, here we go. Yes, yes. So here I'm going to share this with you. This is what it would look like if you look at the large picture. If you try to take two different pizzas that were cut in the same slices, right? And you try to make one whole pizza, it's going to look like one of these Chuck E. Cheese pizzas like this, okay? That's kind of the idea here, right? Yeah, that's the Chuck E. Cheese pizza conspiracy. Is that they take they take pizza that wasn't like eaten, and then they'll add it to like another pizza that wasn't totally eaten, and they're like, okay, happy birthday, kid. Here's a whole pizza. That's the conspiracy, okay? But how would you feel, right? And that's how you can decide, does this work? This is where we put emotion into math a little bit, because sometimes you got to think to yourself, well, yeah, I could put this little piece of pizza and it will fit on that big one. No, but how are you going to feel if someone were to bring that to you, right? You'd be like, hey, you're ripping me off, man, right? Um, and so you got to take that into consideration because there's going to be a part of you that's going to fight this, right? Remember, a lot of you guys on the first day, I said, you're going to experience some emotions here. It's going to be like fight, meaning not literally fighting like with your fist, but feeling aggressive towards this information, or flight, meaning you get so freaked out you just want to run from the hills, right? Or you freeze up and you're just like, deer in the headlights, don't know what to do, right? So what I'm trying to do here is kind of, bring this argument into like, hey, if someone to actually give you this pizza, you would be mad, right? And because it doesn't work. Because really fundamentally, it really doesn't work. Even though they've been cut into fourths, this one right here is smaller than the other. That's not going to work, right? So there's something to think about, okay? So this 1/4 and this 1/4 does not equal. And hey, look at this right here. Let's kind of give attention really quick to this symbol right here. So that symbol right there is the opposite of equal. It means not equal, right? So what the line slash, that means nope, these are not equal in this case, okay? Okay. So let's go ahead and okay, let's look at the skill check. Okay. Yeah, we just answer this question really, guys, just really quick. So so does this, going back to ice trays, right? Or we talk about Chuck E. Cheese pizza if you want. Does this Chuck E. Cheese pizza plus this part of leftover Chuck E. Cheese pizza, does that equal a whole new Chuck E. Cheese pizza? Right? Is that true or is it false? Right? You answer that question in your heart of hearts, right? Okay. And then, if you go through this, you'll see what the answer is. Okay. Um, okay. So I got you for about 10 minutes and then we got to call it. So fractions must have the same denominator. Okay. They have to have the same bottom number before they can be added together. So to add fractions with the same denominators, we add the numerators, meaning the top numbers, together, and then we place that over the denominator. Notice we don't have the denominators, okay? Because remember, it's like, think about the ice trays. It's not like so think about two ice trays, and those ice trays have 5 spaces. It's not like we're connecting them together and like Legos and getting a super gigantic ice tray, right? No, we're not doing that, right? You're taking one piece from the ice tray, you're moving it to the other ice tray. So now you have 2 pieces in one ice tray, you're getting rid of the other one. Okay, that's what we're doing. So we just add the top. So now we have 3 pieces of ice, right, in the ice tray. And there's still, 5 spaces, right? Just 3 spaces are being filled. And so our answer would be 3/5. That's how we would write it. So we would read this as 3/5, right? With a th at the end. Or we could say 3/5, but 3/5. It's always good to get used to reading fractions properly. Okay, let's take a look at this example. Let's work the example, guys. So we have 3/10 plus 4/10. So the denominators are the same. So fractions can be added together because they are the same. We're like, okay, that's cool. This is easy mode. And the first question, whenever you ask, that you should ask yourself when you're doing fractions is, are the denominators the same? There's 3 steps when you're solving addition, when you're adding fractions. Right now, we're just focused on the first step, which is, are the denominators the same? And if the answer is yes, you're cool. You stop right there. This is easy mode, right? Because then what I can start doing is saying, okay, well, the denominator is the same. So I'm going to just go ahead and write the denominator here. Let's get into the habit of doing that right now. We're just going to write the denominator here. And then we're going to do the math up here. So we have 3 plus 4. That's going to give us 7, right? So we should have 7/10. Okay. Once again, work the example. Don't just let it kind of pass over you. Okay. Three plus 4, 7. Yeah, that's true. Yeah. Okay. Do not add the denominator. Okay. So let's try this one. Now you might see this is where, like I said, right? I said fight, flight, or freeze. I bet you there's a couple of you that looked at this and started to panic. You still felt that little part of your brain, right? You look at all these numbers and you're thinking, oh my gosh, I want to run. Or just like you just freeze up and you just go, oh no. Or maybe you get a little angry and you're just like, why do I have to do this? Right? Right? Both reactions are natural, but then you have to remember, right, that if you follow the rules, you're going to be okay, right? Because the same rules apply here. That's the cool thing about math is that math may not be like what you see is what you get. Like I said, math is very representational, but math does have rules, okay? And oftentimes these rules are constant and consistent, right? So once again, I'm going to be an optimist and I'm going to say, okay, I already know I have the same denominator here. So I'm just going to write the denominator and then I'm just going to do the math on top. So I'm going to add the numerators. 5 plus 3 is 8, right? And then 8 plus 7 is 15. So we have 15 over 25, right? There we go. Just checking time. Yeah. Okay, guys. So that's kind of the idea here, okay? As far as adding the same denominators, all right? We'll pick up next week. We'll kind of, clean up on the rest. And then what we'll do is we will next week, or not next week, what we're going to start doing next week is we're going to bring in last week's lesson or the lessons from the last 2 weeks, which is factoring and reducing, right? We are going to, take a look at that before we get into the second chapter, okay? So we're going to kind of revisit that a little bit, okay? All right, so that's it. I do have to get going. I have a meeting, so I got to start breaking down, guys. So I'm going to stop recording right now. Hopefully this was a very useful lesson. I hope I got the basics of understanding fractions across to you guys. All right, so talk to you guys later. Take care. I will see you tomorrow. If I don't see you tomorrow at all, have a happy and safe Halloween. I'll see you next week. But if I do see you tomorrow, take care. All right.
Goodbye, Mr. Gomez.